Okay, hello to all you aspiring hackers out there. In honor of PicoCTF starting next week, I have decided to do a little slow run of some of the exclusive challenges they made available to practice, in this case, the skill of reverse engineering. So, I'm Dr. B. Let's get hacking. First thing you want to do is head over to PicoCTF.org. Right? Go ahead and, if you haven't created an account already, create your account, get logged in, and after you do, you're going to hit the practice button. Okay, so practice at the top here, and that is going to load up a bunch of practice challenges, right? So if you're interested in maybe playing PicoCTF for the first time, or maybe you didn't do the reverse engineering challenges in the past, and you want to know what they're like and a few strategies, that's what today is about. And so in here, we want to kind of filter, right? PicoCTF has been, kind enough to make a lot of their challenges from previous competitions available, but they've also made this PicoGym exclusive, right? So here's the practice gym with some challenges for us. So what I want to do is look at those challenges, and we're going to filter for reverse engineering specifically, right? So you click those two buttons, and we have, just a few reverse engineering challenges here. We're going to conveniently ignore the fact that I accidentally already submitted the flag for one of these that I tested out here. So, and what I also want to show is that, you don't need any special tools to do this. They have also graciously provided us a web shell. So if we actually go ahead and just click this button, there is a web shell that is available for your account where you can just kind of type in, Linux commands or whatever you need to do, right? And be able to work with it. All right, so the way I'm going to do this is I don't really want a tiny little web shell window like this, so I'm going to hit this button to pop it out and make it a whole new tab, and I'll get logged in on that one as well. Perfect. All right, so this allows us to go ahead and work on these challenges. So let's start right from the beginning. I'll just go straight in order. Right, so we have a first one called Ascii for the win. Right, now I'm going to show you a little bit about my strategy with how I approach each one of these, right? Whether you think it's an easy challenge or whether it may be a more difficult challenge, it really is nice to have a methodology for working through them, right? In case you get stuck or you move on to something else and need to come back to it. I like to make a new file and folder, copy all the instructions for each problem I attempt. And let's see that happen right here. So I've already made a folder called gym. I recommend that as well, right? Any competition you're going to go into. In this case, I'm just doing the practice gym. And within there, I like to make a folder for things like the different categories. So in this case, we're going to be doing a bunch in the reverse engineering category. So like you can see, there's not much in here. There is a README markdown file, which we'll come to in a second. So I'm going to make a directory for Rev, my reverse engineering challenges, and I'll CD to that. I should wonder if I can make this any bigger. There we go. That's maybe a little bit better. Okay, how about that guy? All right, perfect. All right, I'm going to hit Control L and clear the screen every once in a while here just so it doesn't get too cluttered. And what we'd like to do is start our first challenge. So what I want to do is I'm going to basically take the name of it, okay, and make a folder for that kind of challenge, right? So this is a 100-point challenge named Ascii for the win. Sometimes I put that point value in, but these are all the same. So I'm just going to make a directory called Ascii for the win. And I'm going to go over to that directory. Now let's go ahead and copy that README file over, and I'll talk about that here in a moment. So what I'm doing is I'm going to copy, it was back here, it was called README. It was a markdown file, and I'm going to copy it into this directory. Now, what it is that's a template that I made for kind of working through these problems and keeping track of what we've done to this point. So there are several options to copying, right? In this case, I copied it so that it's kind of read-only. This isn't 100% necessary, but if you don't want to mess up your template file, you can do this. So I'm going to say no preserve equals the mode. I believe that's the right option here because that's not readable. And so what I want to do is make it so that, sorry, it's not writable. So I want to make it so that the copy that I've made over here does have writable permissions, so you don't really necessarily need to worry about this too much if you don't want to also protect your file a little bit more. But now we can take a look at this. I'm going to open it up in Vim. And what you can see is it's a really, really basic markdown file. A lot of people like to do these challenges and post a write-up to like GitHub or something like that. And this allows you to be just kind of ready, right? If you're just always putting your challenge content directly into here, then you're ready to get it posted. So what I can do is I'm going to head on down and I'm going to paste in the challenge content that I just copied from the other window. Right, and that's basically the description of what needs to happen here. We see some cool things like the author who wrote it, and also the point value, difficulty. These are things I kind of do like to keep track of. So I can up here write challenge, which was Ascii for the win. Category is reverse engineering. And I may not go through all these steps each time, but I do want to show you how we get this done here. Right, it's 100 points. You might say it's like a beginner or easy level challenge if you want to make it qualitative instead. All right, and then kind of the status here, right? I just retrieved this problem. I haven't really done anything with it yet, but I'll put it on. I've started it. Okay, so I like to say, it's either I just got it and I haven't done anything with it, or I started it, or maybe I got stuck and had to move on to something else, or I've completed it. Right, so some status where if you come back into this directory, you know where you are with the challenge, right? And then details is going to allow me to maybe hide some hints in here. Sometimes they give you hints, and whether or not you want to use the hints is kind of up to you. So what I generally do, I'll show this right up front, is these hints are available. Maybe you need them, maybe you don't. But if I'm archiving this for something that I'm going to have later on, I like to kind of give myself the option. So what I can do is I can copy it. I'm just pretend I'm not even reading this right now. You don't have to read it if you want to still make it hidden for yourself, but I'll just kind of copy them into my file. And right away as I do it, right, again, not reading it, I'm just kind of preserving it. What I'm going to do is I'm going to go back into normal mode. And in Vim, if you do G and then 2 question marks in normal mode, it's going to rot13 encipher your or encode, the text in that line. So I can do that for kind of any hint that comes up here. This one had 2 hints, so I'll just do it for the other hint as well. So I'll just hit 2 here. Again, I'm not reading it. I'm just kind of copying what's in this line and pasting it into my file. Hitting escape to go into normal mode, then G and 2 question marks, which will now rot13 it. So now there's hints that are there, but they're kind of obscured from me in case I want to check them out sometime later, but don't want to ruin the surprise if I want to solve this on my own right now. All right. After that, I just want to have the steps of, hey, what is it that I did in order to solve this problem? Or if I'm stuck on it and moving on to something else, what have I done so far that I can pick up on later on when I come back? And the final part being the flag, right? Once you found the flag, document it in there so that you can make sure you get your points, right? And that's, I think, everything that I need in order to kind of get started with this. So what I'm going to do is I'm going to exit Vim here for the README file in this directory. And if we looked back at the challenge, we can see that they've also given us a file that we need to do some kind of analysis with. So that's a link here. And we're going to go ahead and copy that link. Now they tell us we can use things like wget with the links they give us here, which is, it's a command line browser, downloading tool, for lack of a better term, that will go ahead and fetch. It will go ahead and fetch whatever artifacts you need off the web. So we go ahead and we've got the file now. If we do an ls, we can see this ASCII for the win file. Now I wonder what's inside of it. So let's go ahead and open that with less. Actually, probably the smartest thing for you to do in general is to type file on some new file that you've downloaded, because it will tell you, what type of file it is, or at least that it indicates to be by the header bytes inside the file. And in this case, we actually do have an executable, a Linux executable file here, which means lessing it wouldn't have been super helpful. But maybe there are some other ways for us to determine what's going on with it. Some good news that we see here is that it's not stripped. So we see not stripped, which means symbols are left in this file. So this is, kind of a typical executable that we might get on a challenge. What I'd like to do now is I'm going to go ahead and open up tmux, because it's very helpful to be able to work in multiple windows as need be. So for instance, I'm going to open up in one window. If we look, we have basically two files we're working out of here. One is my instructions, my working walkthrough, and the other is the file that I'm analyzing. So let's open up our instructions here. And what I'm going to do is I'm going to split the pane. In tmux, you can just say Control B, and then the percent sign will give me a nice vertical split like so. And now I can check out the executable file. Now I was told it's an executable file, but if I do an ls-l on it, what we can see is it is not actually executable right now. There's a couple hints, right? It's actually just in white text, and usually Bash will have highlighted it green. So there's a couple ways I knew that it wasn't executable yet, so I can't run it. If I want to make it executable, I can do a chmod and add the executable flag to it for Ascii for the win. And now we can see it is actually highlighted in green, and if we do an ls-l, we can see that the executable bit is set for all users. Right. And so with that, we can get to being able to actually analyze this code. If I take a look at it, what ways can we analyze this code? Well, I can do strings, which will show me kind of whatever's printable inside of this file. So if I do strings of it, right, and there might be a lot of strings, so I'll pipe this to less. I don't know what to expect inside of here yet. It's telling me, hey, I see an interesting string here that the flag starts with %x. Okay, that's kind of interesting. And so that's one of the things I might pull out. There's some format string in here that starts with %x. So as a step here, I might say there is an interesting format string that looks like this. Wrong copy buffer. Where is it over here? There it is. Should be able to. Oh, and this is where I forget that I'm using the browser. Sorry. Okay. So I might actually have to use the real right-click copy and paste functionality. All right, so that's what it looks like. So flag starts with, and it looks like it's going to give me a hexadecimal value of some sort, and then some value to follow it. All right, save it as we go along. It doesn't look like there's really anything else that's interesting as far as strings inside of here. I don't have some password or flag just automatically divulged to me. That's a shame. All right, what other things can I do? I can look at the code. Why don't I try to analyze the code? We can do that with the program object dump. So if I do object dump, I want to look at the disassembly, and I want to look at it in Intel syntax, because it's a lot nicer than AT&T syntax in many people's opinion, but of course that is just an opinion. All right, I like to pipe that to less as well, because again, there's a lot of stuff that would have just scrolled. By the way, if you haven't done less before, right, if I had not piped this to less, it would have just done this object dump, and it would have had several pages of stuff just scroll off the screen, bring my cursor back to here, but I would have missed everything that happened above it. It's just really nice to actually pipe that into a pager where I can hit the space bar like so to go a screen at a time, and the B button to go back a screen at a time, and see all the content that's in there that's important to me. Right. And as we do that, I can see that I've get down to here's where the main function is. So we know, like a lot of C programs, the main function is where important code begins. And when we do that, we can actually see something kind of interesting here, right? Which is that this buffer here that starts at RBP minus hex 30 gets a value here. So it's a byte pointer. So it gets a 1 byte value. And then we can see we go to the very next location in memory and give it another 1 byte value. The next piece of this, so we can see that happens quite a bit, going all the way down to here, this RVP minus hex 12. All right. Another real interesting thing is, which takes a little bit of experience, but if you actually look at these numbers here, what you will notice is every single one of these hexadecimal values, these 1 byte values, is printable Ascii, right? If I looked up these numbers up on the Ascii chart, every single one of them would be something that is either like a number or a letter or some punctuation, something that I would be able to print onto a screen. All right. So that tells me this may be the flag itself, just these characters here, if I was able to get them converted over. Okay. I could prove that. Just I don't want to take a whole lot of time doing it, but if you want, when you want to prove that kind of thing to yourself, you have the ASCII table available to you, so you can always say man ASCII. And if you head over to the hexadecimal column here, for instance, here's the 70. So I want to find hexadecimal 70. Okay, so here's 70, and we can see that is lowercase p, right? And if you've been shown our flag format, it actually always starts with the word Pico in lowercase and then CTF as uppercase, and then these brackets. So this looks, convincingly like it might be the first character inside of our flag, right? Now you could one by one go through every single letter on this table to find out where it is in the ASCII chart, and you could build your flag that way. That's perfectly fine. Okay. There are some other techniques, however, that you could use as well. I want to do something maybe somewhat straightforward here. So I was thinking about doing a binary patching for this. It's not really necessary. Why don't I do something where I isolate these characters and then just print them for us? So this looks like it's the characters of the flag. However, the problem is if I come out here and I can see it kind of from the code, especially with our format string, it looks like our format string is only showing us potentially the first character. So if I actually look at this, and I do ASCII for the win and actually run it, it tells us exactly that. The flag starts with, and it shows us the 70, which is what we saw the hexadecimal value was for just the first character. But I want all the characters, all right? So how am I going to extract them, right? Several options here. I think no way is a bad way. But what I'm going to do in this case, kind of interesting, is pull them out in a semi-manual way and have Python show me what the answer is. So what I'd like to do here is I'm going to zoom in on these bytes, and I'm going to capture all of them, like so. And I'm going to remember to actually copy it this time. Head back into my other window. All right. By the way, it's Control B to zoom into a window, and then Control B Z to zoom into a window, and then Control B semicolon will switch which pane you're in on your screen. All right. If you're interested in what these Vim commands are. So now what I want to do is I want to go ahead and insert those lines that I just got here. Oh. Failing to remember which copy buffer to use. All right, we brought it out. We're going to go ahead and copy these lines over. Sorry, paste these lines over. Right. Now, as you're going along, right, you're making your write-up, so don't forget to give yourself some indications of what it is that you've done. It looks like each byte of the flag is loaded into a buffer below. We just need to get them translated into a standard string. And that's what we'd like to do. What's great is that we have Vim here. So what we can do is find things that are interesting inside of our string that's happening in each of these lines. And it looks like there's one comma, right? There's exactly one comma that's right before the number that we're interested in. And we're not really interested in any of the other stuff, right? These are addresses for the code as it's showing me, hey, what are all the different individual characters inside this password. So what I can do is I'm going to go into normal mode with escape. I'm going to hit the colon key, and I'm going to substitute all the characters. I believe it's .star. There we go. So this is actually nice. So it's the kind of version of Vim that shows me what I've selected inside of my regular expression here. And I want to do all the characters up to the comma. So we can see, in this case, it selected everything up to the comma, from the beginning of the line up to that. And I'm not actually interested in any of that. So that is the entire string. So I'm going to put another slash there. And I'm going to now say what I would like to replace it with, right? If I wanted to replace all of that with 2 dashes, I would put 2 dashes here, right? But as it is, I don't want to replace that with anything. I just want that deleted. So I'm going to put nothing between the last slash and this slash, right? And if I do that, there we go. I've gotten rid of all that, so now I just have that number, that hex number 70, right? So what I'd like to do is do that for all of these lines. And so one way to do that is I'm going to head to visual mode here. And in normal mode, I'm going to hit it's capital V, so that will select the whole line. And then if I hit the right curly brace, it's going to basically select the entire paragraph where these lines of code were. And I'd like to just basically do the exact same thing. So I'm going to substitute. The dot means any character. And this, if you're looking at the bottom left of the screen, the dot means any character. This star means any amount of them repeating, right? So any character, and that is why the whole line is getting selected, up to the comma, right? So any characters ending with a comma, like so, which I'm going to delete for all of these lines. And there we go. Now we've just isolated the hexadecimal characters that we're interested in. All right, what can we do now? I'm going to use basically the exact same trick. I'm going to head back up to the beginning of this character, of this paragraph, and I'm going to use my capital V to go into visual mode. I'm going to use the right curly brace to select the whole paragraph. And now there is yet and actually I could have said lowercase g and capital V, I think would have recopied the whole last selection. But either way, as long as we get it selected here, what I'd like to do now is I'm going to hit capital J. And what that will do is it will basically remove all the new lines between everything on all these lines here inside my selection. Right, and what you can see here is I'm getting the beginnings of a Python list that's going to make this a little bit easier for me. So what I'd like to do is hit capital I to insert at the beginning of the line, because I'd like one of these brackets here. Then I'm going to hit escape to go back to normal mode. And I'm going to hit capital A to insert at the end of the line, and that's going to be just a bracket. And the only other thing I need to do to make this look like a real Python list, if I hit escape again in normal mode, is now I'm going to substitute. So I hit colon, S for substitute, and I'm going to substitute the space character. Any space character I see, and you see it just highlighted this first space in between these two numbers. And I'm going to replace that with a comma. Okay? So comma separating our values inside of the list. Right. Well, that would only do it for the first spot here, and I want to do it for all of the characters, right? So the way I can do that is I have a special command I can give here with a G and make this a global substitution. So all the spaces on this line should now get substituted with a comma, okay? Which we do see happen. All right, that's great stuff, because now I can, I'm going to zoom into this window here so that I can copy this entire line. Right, and actually copy it. And then I am going to head back to the other window, and since I no longer need that object dump, I'm just going to head into Python. I'm going to make a string of my characters, which is coming out of this list. So I'm going to paste this list. All right, so now we have a list of all these numbers, which can now individually be converted over to ASCII characters with the CHR command, right? So if I do CHR, and let's say this first one, the 0x70, you can see that it will give me that lowercase p, just like we saw before. I'd like it to do that with all of these characters. I could certainly write a for loop to do it, but Python has other Pythonic ways of getting this done. So I'm going to create a flag variable here, and I'm going to use a list comprehension to do this conversion for me. In fact, I'm not going to use a list comprehension. I'm just going to directly map it. So I can say map CHR to that array of characters, like so. All right. which is going to give me this iterable. And what I'd like to do with that is I'm going to join that into a string, like so. Okay, there we go. Okay, so I'm going to map each of these characters, right, inside of the inside my list into an actual CHR or character that's a string character, and then I'm going to join all those characters together with really nothing, so nothing in between them. I could join them with commas again if I wanted to, or dashes, but I just want it to look like a normal string, so I'm putting no characters in between them as I join them. That's what I'm getting here. So it looks like I didn't get any errors, and now I should be able to check out my flag, and there we go. It tells me my flag is ASCII is easy. All right, now I'm going to do two things with this, right? One, I'm going to copy it, of course, because I've now solved the problem more than likely. Did I copy that correctly? I'm just going to do it again in case. Okay, copy it. I'm going to head back, Control B, semicolon, and I'm going to record that as being my flag. All right, so if I insert and paste it, I can't shift insert here, unfortunately. All right, I get that. Now, a couple of these characters aren't going to be great for Markdown. You can, I'm not really going to get into the doing all the Markdown pieces of this, right? You can modify as needed for your final version of things. But now that's my flag. I should have been able to paste it back here as well for this challenge. And when I submit the flag, I get a nice green bar saying, hooray, I earned the points. Okay, so that looks pretty good, right? That's one way to solve challenge number one, right? And now with that, it looks like that flag was correct. I've already got some decent details for what I needed to do. It might have been better for long-term a write-up here of having left the original instructions that I copied over and then make a copy of how I brought this into a Python array. You could make what you did in Python here as a solve.py program as well for long-term storage. But again, this was just a couple of pretty simple instructions. You could, if you wanted to, and why didn't I do it just now? Because I'm saying it, just to make it sound like I'm taking my own advice. But right here, what we can do is converted in Python, right? And you can just copy over a couple of lines here. So I'm gonna, copying is not great in Tmux, I'll be honest. So I like to zoom in on the screen first. So you can just do this guy here and grab the work that you've done. Control B semicolon, come back over, and then go ahead and paste it in here in insert mode. And so we can see here's the actual code that I did in Python. Again, you could save it into a Python executable, so you could run it for an easier solution next time. But at least you know what you've done, right? With some of these easier challenges, you don't necessarily need to, save that solution. All right. And so the very last thing we want to do with this file here is update our status, right? You could do this later if you wanted to, right? I'm not, again, rushing through these challenges, right? If you were like, oh my gosh, I got to get points to stay on top of the leaderboard, you might say, I'm going to come back and do some of this stuff later. But if you're doing this to learn, which is probably the most important reason to do these, it's good to have stuff that's documented to help you in future challenges. So now we can probably change our status to something like completed, right? Which we'll now know that that's been done in the future. All right, so we have just solved our first challenge. I can go back over here and exit Python, right, and get ready for our next challenge. All right, so our next challenge is this bit.o.asm1, right? So I'll do the exact same stuff. I probably won't describe it in gory detail each time now that you know kind of what we're doing, but let's make a directory for it. Make directory. We're going to go back up one level here, and it's going to be bit.o.asm1, something like that. We'll cd to that directory, which again should have nothing in it, but it would be good for us to go ahead and copy that README over. Now, we have that cp command that does the no preserve for our README file. Again, if you're doing this with a template, you could remember this no preserve thing, or right, you can make yourself an alias, and I believe that I did update my bash rc. So I made this alias to do copying with this preserve option in there. So I'm going to be doing that for the rest of the time here. So this cpre command will let me do that. So I'm going to cpre this README file to here. All right, so now I get the README file, and it is something I can write and modify. All right, so I'm going to vim that. And toss what we got there into our description. Great. All right, so we'll read this as we kind of maybe fill out some of this stuff here, which is, hey, the challenge is bit O ASM 1. Okay, it's still reverse engineering. All right, another 100-point challenge. All right, and now we need to figure out what is in the EAX register. All right, we can put our answer in the PicoCTF flag format. Right, PicoCTF N. So N is going to be the contents of whatever is in our EAX register. Okay, good. I think we can get that done, right? And in decimal, right? Decimal base number. So it's not going to be hexadecimal or octal or anything like that. Really important to follow those instructions. All right, so I've got this over here, and we are getting this started. All right, let's see if there's any hints for us that we're not necessarily going to read right now. But as we are getting them documented, I'll just toss them in here. So here we go. We'll go back to normal mode, G question mark, and it's obscured for us. All right, and now we're ready to kind of put in our steps if need be. All right, so we are going to exit this here and head back and grab our challenge material. So there's some dump that we grabbed, so let's go ahead and copy it and wget it onto our system. Good. All right, now it's telling us that it's a text file. Now, I mean, always you want to double check, right? So I'll go ahead and run file on it anyway, but it's confirming that there's ASCII text inside of this file. All right, so there's some kind of disassembler dump. And if I open this file up, it looks a lot like what I saw in that main section of the object dump last time around, but shorter, okay? And it doesn't look like there's really much to this. So what I'm going to do, I'm going to hit Q to quit this view, and I'm going to go back into my README. And what I'm going to do is I'm just going to go ahead and put the contents of the file here. In fact, I'll even make another header for it, right? This isn't something I normally do, but I'm going to say code. All right, and what I'm going to do is I'm going to read this in. So I'm going to hit escape, go into normal mode. I'm going to hit the colon, and R will read the contents of a file into where your cursor currently is. So I'm going to read that disassembler dump file. So it's everything we can see here. So we can do all of our analysis likely right here inside of our README file. Okay, and if we hit capital A, we're ready to write down our steps. Okay, now again, let's not forget what we're supposed to do. What's in the EAX register? Okay, when this all wraps up. Now we can see something happens with EDI, RSI, but those are actually just getting read. And then after all said and done, we see a move, right? EAX and 3.0. Now, if you haven't read a whole lot of assembly language, x86 in particular here, and Intel syntax, the destination actually comes first, and the source comes last. So we're actually taking the value 0x30 and placing it in the EAX register. Okay, so the important line is this. So what I'm going to do is go ahead and, gosh, I always forget when I'm doing this. Okay, the important line is this. In fact, I'm just going to use Vim here. I'm not going to do anything fancy. All right, we can yank it with PyY, and I'm going to go ahead and just paste it down here. So here's our important line, and this is the only line that modifies EAX. And so the EAX is equal to 0x30. Right? However, this is hexadecimal, right? So in order to get our flag, right, our flag needs to be PicoCTF. We got told that's the flag format. And then we're going to have n in here, which is a number, okay? But that number needs to be in decimal format specifically, right? So we need to convert 0x30 into decimal. I'm going to show you one way to do that, right? So, right, you may be able to do this in your head. Recognize that base 16 means we have 3 groups of 16 right here. So that should give us the number 48. Okay. But if you're not super confident in your math skills, what you can do is in the place where we're going to paste it down here, we're in insert mode already. And in Vim, we can hit Control R and equals. And now it gives us a register that we can put some math into. I keep putting the wrong things in there. Sorry. I don't even think I copied it, but it doesn't matter. We have the number there, right? It's hex 30. Let's say we don't know what hex 30 is. It's going to go ahead and just convert that for us and show us that that number comes out to be 48. Okay, so that should, if we've done our work properly, that ought to be our flag. So let's go ahead and copy that. Bring it over here. This is going to become a meme here, which is just great. And let's, actually, did I actually copy? I wonder if I did. Copy it and actually paste it over here. There we go. All right, so did we get that right? All right, okay, good. I've solved this challenge correctly. Again, all right, that we worked on before. Now, we can make our screen a little bit less cluttered by hitting the hide solved. So I've already solved 2 challenges here, and what they will let me do in this UI is hide solve challenges. So I'll only see the challenges that are yet to come. So I'll just tackle whatever's in the top left corner here as we continue to go through. So now we're going to hit this BitOASM2 challenge, right? But first, let's go ahead, and since we've confirmed that we've completed this challenge properly, let's go up here, and since we have our flag in, we're going to mark it complete. Okay. Now, the next challenge was, again, BitOASM2. So it looks a lot like this one here. So I'm going to make a directory, BitOASM2 in this case. Head to that directory, and we're going to copy our README file over from way back here. Okay. And we're going to start it up. All right. I may, in the interest of time here, forego putting in all the details because I think we know how to do that. So the training value of that is probably taken care of. So we can paste our instructions here for BitOASM2. Our instructions look pretty similar. What's in the EAX register, right? Same flag format, in decimal format, okay? Great. So let's go ahead and start this one. Okay. All right. I'll also not do the hints unless we need the hints from here forth. All right. So what are our steps that we need? First things first, we need to actually grab our file. So we're going to copy the link here for this BitOASM or assembly. Okay. And I'm going to go ahead and download it. What I'll do is I'll just make a new window here. And our settings aren't awesome for Teambucks here yet, but not a whole lot to be gained for doing this for just one little walkthrough. Okay, so what I'm going to do is I'm going to go ahead and wget that. Okay, so now we have the file. I can less it again, just disassembler dump, text file. Again, not a whole lot going on here, so I'm going to do the exact same thing I did last time and kind of try to simplify my analysis by just including it right here. inside my README. I'm going to read that disassembler dump that's now in the same directory we are. And lo and behold, this code doesn't look very much different, right? Something happens with EDI and RSI, but those are just getting read, right? Because this is the source, right? Those registers. Here we have a value being moved again into some location in memory, this RBP -4 location. And the very next line, that same location, RBP -4, is getting stored into EAX. So it looks like, this is two instructions that take this value here and move it into EAX. So that's probably what we're interested in. So let me go ahead and I'll do the same thing and copy this over to YY to yank them. I'm going to paste it here and say, these are the only lines that affect EAX. Okay. And so the EAX value, all right, so the EAX value is probably this guy, which I guess I have to do the long copy and paste every single time. That's fine. And so in our flag format, we need to make sure that it is the decimal format of that. So I'm going to hit Control R, the equal sign, and I'm going to yet again paste it. And it should convert that number there into decimal on our behalf. Okay, I'm going to go ahead and save this file here. And now we can check if we got the file right. So let's copy it, bring it back over, paste it in, and bingo. All right, looking good. All right, looks like we have a couple more of these left. Maybe they get slightly harder in difficulty here. I'm going to go ahead and streamline this a little bit. I'm going to copy the description for BITO ASM3 as I wrap up BITO ASM2 and mark this guy complete. And I'll do the exact same. I'm going to make the directory of BITO ASM3 here, change directory to that guy, and copy over my README template to here, and take a look at it. In fact, no, I'll do that. Sorry. All right. So many different ways you can try to streamline exactly what you're doing, but it's fine. I'm going to paste this in here. So now we know what our instructions are. Again, looks very similar, right? What's the value in the EAX register? PicoCTF end flag, and we want the decimal number of what it's going to be. So possibly some more analysis to happen here. We shall see. All right, I'll just exit it here and prepare this wget because they should be giving me a file. I'm going to copy this link over and paste. All right, so here we got disassembler dump C. Looks good. You can see I have both files here. So what I'm going to do is I'm going to head back into my README. I'm going to kind of assume possibly that the code isn't too onerous. And so I'll just basically do the same thing we've done here to just try to get our analysis all done in the same place. So I'm going to get to normal mode and read in the disassembler dump C file like so. And again, it's not too bad. So we'll hit Control E and scroll up on the screen a bit. So now we again want to figure out, hey, what is the value in EAX? We see that longer value over here, and it goes into this location here, base pointer minus C. We have 4 going to this other location right here, base pointer minus 8, and then we move this C value here into EAX. Okay, so after that point, we do a multiplication, right? Integer multiply of basically that value that's in EAX with this value that was in RUP minus 8, which is a 4. Okay, And to that value, whatever that is, right, we are going to end up adding this value here, hexadecimal 1F5. And then we do a couple of things that look really odd, which is we're going to take that value in EAX, put it into this REP minus 4 location, and then put the same thing back into EAX. All right. So from that, we can maybe get an idea of what was supposed to happen. We're going to say at the end of all of this, oops, okay, didn't mean to do that. We're going to say at the end of all of this, EAX is going to be equal to, we're going to have this value here, right? And what we saw is that value in this multiplication is getting multiplied by, right, this REP minus C value here, this guy. It goes into EAX and is getting multiplied by this REP minus 8 value, which is coming from here. And the source of that is this number 4. So we can see there's a multiplication between this value and the number 4, right? After that's done, right, that gets, here's our destination, which is EAX. And to that, we're going to add this value here. So to that whole quantity. So now we have this whole quantity here, like so. And we're going to add this value to it. Okay. It's not entirely necessary for us to know exactly what those values are, because again, we have ways of converting. So we know our flag should look like PicoCTF, Control R, our equal sign, and we're just gonna try this yet again. Will this also do math for us? Oh, okay, looks like it. So converted these values from hexadecimal into decimal and showed us what this whole equation should give us, right? And all this time we're just doing static analysis, right? We're not even getting the actual binary here, right? It's just showing us what some of the code is and giving us opportunities to do some of the analysis on our own. Now, you could, right, if you were, working way back in reverse engineering, you could figure out, hey, what is the, kind of C function that is more than likely actually happening as we've done this, right? You could have said something like, hey, there appears to be a couple of variables here, right? This -8 variable, this -C variable that we saw along the way. So I could say like, hey, this is like an int, A and B right here, right? And I could have said, hey, A equals this first value. Okay, and the B equals 4, as we saw, right? You see hex 4 and decimal 4 are really the same number. Okay, and then what I ended up doing is storing them both into this value here, this register EAX. Now that's not really overriding one of these. You could say, hey, that's like a third variable here, and sure, I'll just do that for the sake of kind of getting a picture of what's going on. And I'll say, okay, so C equals, A times B, right? That's, I hit something by accident there. C equals A times B. Okay, and then after that point, we then perform this addition here, right, of wherever this value was. Right now we're saying it's in this other integer variable C. Okay. All right. Right now we're saying it's in this other integer variable C, and I think I lost my semicolon. All right, and we're, to the C value, we're adding this this hex 1F5. Right, so you could basically have done this. So you could say, okay, C plus equals this new value 1x5, and I really don't know what I hit to make it highlighting right now, but I'm gonna kind of ignore it for the time being, just to get through this. And then what we could say is, so basically you could now have made a C program here where C, this integer variable c now contains what the answer is based on us doing this, right? So this is typically what kind of reverse engineering means. To get it back to something that you can kind of explain and look at. That's not this kind of real esoteric assembly code, right? So if you know C, then this might be a little bit easier for you to be able to analyze, and you could then do you could say like printf, this decimal value that's currently in the integer C, something like that. All right, to give you what that answer should be. All right, so I'll kind of leave that up there, and we will now check if we got this right. All right, looks good. All right, so that's great. Vim will do a little bit of math for us, right? We didn't need to necessarily get out into Python to evaluate that expression. And so you have a couple of ways, right? You could have kind of seen what was going on and tracked those values along the way, or you could try to convert each section of code into some higher level language like C, or even Python if you wanted to in this case, to get a feel for how the entire thing works. Okay, cool. Fantastic. So we are going to then head over to bit of ASM 4 as we wrap this guy up. Oh, I didn't even do the part here. Okay, so I'm going to delete this word. I'm going to delete these other two words. So we are complete now. All right, so we got the right flag. All right, so we're going to do this one more time. Looks like we only have one more of these bit ASM ones to do. So make directory bit ASM 4. Head over to it. We're going to copy over our README into this directory, and we're going to take a look at it. Head over and prepare to copy over our description. All right, what does BITO ASM4 ask of us? Okay, so we got our description here. Okay, again, looks familiar. What's the value in the EAX register? PicoCTF flag format, decimal number. Right, so potentially some analysis to happen here. So I will prepare for that as well. I'll say, okay, we're going to have our code, and we need to get that downloaded. So we're going to wget. Let's add this link, which should be assembler dump version D. Right. We'll head back into our README, to our code section here, and read disassembler dump version D. All right, there we go. It's not crazy long either. Okay, so we'll move up here as we take a look at, hey, what is this asking of us? All right, now I can see something happening already that's a little bit different from before, which is this new command here, JLE. It's telling me there's a jump, right? A conditional jump if less than or equal. There's also a unconditional jump here, which is going to happen no matter what. Those two things together give me the idea that there may be a loop here that we deal with. So it may not be just, hey, I read this code straight down and suddenly I have my answer. So something else might be going on. All right. So with that, what actually is happening? Again, we're just trying to figure out what is the value in EAX when all this is done. Okay, so we have another value here that's going into this variable, right, on our stack, right, base pointer minus 4 bytes. Great. Now we're going to compare that value to this value here, this hex 2710. And if it is less than or equal to that value, we are going to jump to basically the end of this loop here, right, after the jump that would go backwards, right? So we're going to jump to this add instruction down here at the end. Of course, at the beginning, this number, you can see it's larger than this guy here, so it's not less than it from the beginning. So that tells us a little bit about our loop of what's going to happen in here. Okay. Now, if that's not the case, right? If we're not jumping there, then we're going to subtract, right, from this number here, 0x65. Okay. We're going to subtract 65 from it, and we're going to add. Oh, sorry. Then we're going to perform our jump to 4-1, right, which is down here. Okay. So, I wonder if it is a loop or isn't a loop, right? In this case, it doesn't look like this jump is going backwards. This guy here, this first jump was to main plus 37, which is down here. And this jump here was to main plus 4-1, which is also further down this list. So it looks like everything just moves in the downward direction. And I may not have to do any kind of loop analysis. Okay. Well, in that case, what we are looking at is, okay, is this value less than or equal to this value? Well, we can already determine that this value was greater. So it's not less than or equal to it. So that means we probably should not jump, right? I would not expect the jump to happen. So I'm going to go ahead and I expect that I would subtract this 6.5 value here, okay, from the value that's already inside of our variable. So when all said and done here, I'm going to say, let's say it was like more of like an int a equals, right? We'll say this RUP minus 4 is our integer a, okay? And it's this value here, right? So this is what it might look like in C. And now based on this comparison here, right, it's greater. So we are not going to do this JLE jump. So this means we're going to do a subtraction. So now we're going to say A basically minus equals this value here. Oh, I don't think I copied it. So used to regular Linux shortcuts. So that's why I keep missing that. All right. So now we've gone ahead and done that, the subtraction, and now we have an unconditional jump. So this is going to happen no matter what, and we're going to jump down to main plus 4.1, right? You can also see the raw address here, this 5.1.5.2, but we don't get those raw addresses, so we just have these offsets. So main plus 4.1 is down here, this move instruction. So we jump down to here, right? And now we're just moving that value, or what we're calling our A variable at RBP minus 4, into EAX, right? So that looks like our answer should just be this number here minus this number, right, for our flag. So one way to test that out, you can see PicoCTF. And we're going to go ahead and copy them over. Right, and since we can do the expression here, why not let Vim do it for us? Since it will do the subtraction and convert it back to decimal for us. Oh, I did not do that right at all. Let's go ahead and copy that. Great. All right, so now that I've done that, what I'm going to do is I'm going to go into normal mode, and I'm going to delete what's inside of these curly braces. So that's DI for delete inside, and then hit the curly brace, and that deletes what's inside of there. Now I can go back into insert mode, hit my control R and the equals, and paste that expression that I have, where it should give me this answer. Right? That's an answer I can now copy and paste to see if that is the solution. All right, hooray. All right, one more down. All right, so it looks like that was correct, right? You can give yourself some notes about that. We're going to head back in here. Oops. That is the Vim instruction for going up when you're actually in normal mode, which I was not. Okay, delete 3 words, and now we are complete. Okay, so mark it complete, and we move on. We can see here the next challenge is named GDB Baby Step 1. Right, so if we didn't know, right, GDB is the GNU debugger. Okay, so I may be given some code here that I might or may not need to step through inside of some kind of a debugger. All right, so let's go ahead and click on this guy, and we're going to copy over its details into our web shell. Super convenient. Okay. Baby step. All right. So cd, sorry, we need to make a directory for it. GDB Baby Step 1. All right, cd to that. And now we can copy over our handy dandy README file to here, okay, which we can see. Now let's go ahead and copy our description in of what we're expected to do in the challenge. I think I already copied that. No, I must not have actually copied it. There we go. So now we got it copied and we can actually paste it in. Oh, I guess it is just very similar to the instructions from before. Didn't realize that. Okay, good. So yes, similar thing that we need to do, right? What is in the EAX register when all is said and done, right? A lot of analyzing what's in this EAX register, even in this new kind of strain of commands. Now, something might be a little bit different here. So I'm going to not forget to mark that we're getting this started here. Right. Not good enough. Okay. So what we'd like to do is go ahead and download the file that they're giving us here. Again, there's hints. If you need the hints, you can download the hints. If you want to obscure them, you can obscure them. But they are available if you will need them here. And so what we're going to do is we're going to hit wget. Right, so this is debugger version A. Okay, again, as always, we're going to look at this guy here, and we're going to use the file command to look at exactly what type of file it is, or reports to be. So it's 64-bit ELF executable, right? Dynamically linked. That's important to know. Also, not stripped yet again. All right, all good news. Right. So what we want to do is have a way of kind of taking a look at what's inside of this guy here. So I'm going to open up my notes, but let me open up another window. Right, Control B, percent sign. It's going to open up another window here, and again, I'm going to have to, since Tmux isn't set up the way I would normally have it set up, head over to this, what is called GDB Baby Step 1, like so. All right, so we have this debugger command here. Now, it's an executable, but again, it doesn't have executable permissions assigned to it yet. So we're going to change the mode of access to it, add the executable bit to the debugger, like so. All right, now it's nice and green. We can prove to ourselves that it is executable. We could run it if we wanted to, right? In most of these, it's going to be perfectly fine to run it to see what's going on, if it will show you anything at all. But I run it, and it doesn't actually show me anything at all. Okay, so that means I may need to kind of do some analysis here and see, okay, what's really going on inside of this program. I could open up object dump as we did before, but let's go ahead and check out another tool for this series of stuff. You could open it, by the way, directly in GDB if you wanted to as well. That's also fine. But I like to do some analysis in R2 whenever we start. So R2 is a great reverse engineering framework that has a bunch of capabilities that help you see what's kind of going on inside of a file. So you can just kind of open that up with R2 and the name of the executable, and it brings you into the entry section of the file where the code is. We can then do the command seek to the main section, because that's more than likely where we want to start doing our analysis, especially for introductory binary. And you could then do something like print the disassembly of the main function with this, so you can see what's in it. I didn't do an analysis yet. Okay, and I may or may not end up doing an analysis here. That's fine. So I'm going to head into visual mode for this, and by hitting capital V and enter, And now you can see that we can look at the actual bytes of what's inside of this file, right? Where the main section of code is. And now we can have several different views for this. So I'm going to hit P, okay, the P key, and that's going to print it in a different mode here. So instead of looking at the data, we're now going to look at the code itself. So here are the same few lines of code for the main function. Same kind of thing that we would have seen in object dump, right? And now, when we compare this to the challenges that we just did, where we had a text file that basically showed us these lines of code, we are now looking at the exact same thing, right? And in fact, very quickly coming out over at R2, because we don't really need any comprehensive analysis for this particular challenge. If we do object dump -d, like we did before, with the machine architecture being Intel of my debugger program, and I type that to less, right? If we hit the spacebar a few times and get to our main function right here at the bottom of the screen, okay, that it looks exactly like the bit of text that we would get in our last few files. And what we're seeing here is it doesn't look incredibly complex, right? So what I'm going to do is I'm going to zoom in on this window where the code is, Control B, Z, and I'm just going to go ahead and copy what it's showing me is coming out here for main. So I'll right click and copy this. I'm going to hit Control B and semicolon to go back to my my README, my notes window. And I will do exactly what we did before, which was make a little code section here and paste in this code from the object dump, right? I don't think there's really much else going on over here, by the way. You can see there's frame dummy up here before the main, and you see this libc thing down here afterwards. There doesn't appear, right, at first glance, to be anything else that we necessarily need to analyze over in the object dump. So I'm going to go ahead and close it out right now, unless I'm proved otherwise. So we can focus our notes on just this little bit of code. And we want to know what EAX is at the end of it. And it looks very similar to what we had before, by the way, right? So, these couple lines are just our other registers that are just being read. And then we end up just getting this value into EAX. All right, so this looks exactly what we did before. So I'm just going to go ahead and copy that and set it as my flag, PicoCTF. And we hit Control R, equal sign, and we're going to paste that value. Okay, and it converts it back to decimal for us. All right, so all we really need to do here was object dump of executable. Shows the short main function above. All right, that looks pretty good. We can at least check if that is indeed our flag. All right, hooray again. We got it. So I think we know what our GDB baby steps might look like. So maybe we can take a look through these other ones here and see if they kind of also follow the path of what we've just done with the other executables that we got. All right. In fact, before I get to that, I'll close out the last function here just to be complete. All right. So we got this one done. We were started, and now we are change word complete. CW will change word. Okay, let me type in a new word here if I can actually type it. There we go. So that is now complete. Escape, 2 capital Z's. We'll save and quit. All right. So there we go. We've got our baby step 1 all done. So now let's go ahead and make a directory for GDB baby step 2. Change to that directory, copy over our README file, and get it ready to bring in our description, what needs to be done. All right, so we go into baby step 2. Paste it in. asking something very similar, EAX register, flag format, decimal numbers. Okay, great. All right, so let's go ahead and do a very similar process to what we did last time. Oh. All right, let's split our window here, find that directory, Baby Step 2. Okay, we now are going to need to download the file that goes along with this that we want to analyze. wget this guy. All right, so debugger 0b looks good. I'm going to know that I need to make it executable. I mean, we may or may not end up running this, but let's give ourselves options. Okay, I'm going to go ahead and object dump it again. So less, right? Head to the main function, which we find here, hit spacebar a few times, right? And now we see a little bit more going on. Okay, I've got this happening again here, which I mentioned before. Okay, we have a jump. Okay, and this jump goes to main plus 30. Oh, here we go. So we don't see those offsets on the left hand side, but we do have the addresses. So 401, 136. So 136 we can see is all the way down here. All right, so that jump, which is definitely going to happen, comes all the way down to this move line right here. Okay, then we do a comparison, and then we do a conditional jump, right, to 401, 12C, which is 12C, which is all the way back up here. So this is an upward jump, okay, which is just below where the first jump was. So now we can see this is definitely a loop. All right, so we may need to put some thought into doing analysis of what happens here. All right, so what we can do, I'm going to zoom in on this screen here. Let's go ahead and copy the code over again. Why not? Nothing important looking before main, right? Nothing important looking after main right now, right? Those things can be trickier with more advanced challenges, for sure. Okay, but I'm going to head back over here and copy in the code that we see because it's not too long. Cool. Oh, now I know why that's happening. It's the markdown feature. Yeah. You don't have to name your extension markdown if you don't want Vim to automatically start showing you weird markdown artifacts. So that's another tip. You could just call it readme.txt until you're ready to upload it to GitHub if you like, and rename it afterwards. Okay, right now we'll just kind of deal with it because it's really not that bad. Okay, all right, so what's happening here? We have some things going on. Let's see if we can try to figure out what's happening in this code. We have a first variable here. Let's call this RVP minus 4. So maybe that's going to be our A. So we have some A integer. So int A equals, and it's this value. All right. We've got another one here. Copy. So we'll call this guy int B. We don't really know what they're used for yet. I know we've all been drilled to have like useful variable names, but we don't know what these are yet. So it's a little bit hard to have useful variable names. In fact, what I will do, which is what I often do, is give them something relative to the name of the register that they're coming from, like this, right? So, 4 is REP minus 4, like so. So you can give it a name like that, or underscore 4, something that you might see in a decompiler, right? Then we have the REP minus C. Ugh. C, like so. All right, and we get this value here. All right. Now what's happening? Now we get a value that starts out as 0, right? And then it goes right into our loop over here. I'm going to go ahead and close this other window over here because we probably don't need it anymore, unless we do. So we're closing that window, and now we are going to put this value 0 into yet a third variable over here, right? So it's int RVP minus 8 equals 0. Starts off with 0, right? And that happens right before we get into this loop, right? Now we go into this loop and we are checking, right? We jump down to 436, which is down here, this move, right? And so we're looking at the value in RVP minus 8, which is 0, and comparing that to the value in RVP minus C, which starts out as being hex 25F, like so. Okay, and if it's less than that, right? So we're saying something like if RVP minus 8 is less than what's in the current location of RVP minus C, like so. If that's the case, this is pseudocode right here, okay? So if that's the case, then we're going to basically jump, right? If it's less than that, we're going to go ahead and perform our jump. And our jump is going to go all the way back up here to the 2C, right? So 1, 2C, which is this guy here. And then we're going to be doing this addition. So we're going to head back here and do that. So this addition is going to say, hey, we're going to put the value that's currently in EAX, okay, into base pointer minus 4, right? Oh, wait, am I on the right line for 2C? There we go, highlighted. This one right under the jump. So we're going to take this RVP minus 8 value, right, which is currently 0, and move it into EAX, okay? And then we're going to move that, we're going to add that, sorry, to the RVP minus 4. So right now that's 0, and we're adding it to this, this variable here. So inside of here, we're saying RVP minus 4 plus the RVP minus 8 value. Okay, so that gets added to RVP minus 4. So actually, that should be more of like a plus equals. Okay, so we see it gets stored back in there, right? And so now we're going to take a 1, and we're going to add that to the RVP minus 8 variable. Okay, interesting. Okay, so then on the next line, we see RVP 8. You can basically do a plus here if you come from C land. All right, so that gets incremented by just 1. Right. After that point, we're going to look at these values again, right? This RVP minus 8 value, and we're going to do the comparison to see, hey, are we staying in our loop? All right. Now, if we paid really close attention here, something that did not change was this RVP minus C value, right? This 25F. So it looks like that is this constant point here. And you could probably write out an entire for loop, right? Saying, hey, my 8 starts at 0. I'm going to be adding 1 to it until it gets up to this value here, this 25F location here. And this is what's happening inside is I'm adding to this RVP minus 4 value. Okay, so it would look something like 4. And now I'm going to replace, because we can see that RVP 8 is some kind of loop incrementer. That's normally like our I. So something like 4, int I equals 0. We're going to add, right, while I is less than this value here, this 25F value. We can basically hard code that. Okay. And then we can say I plus plus. Right? So we're just going to be adding 1 each time that we go along while it's less than this value. Right? And now, what are we doing? There's only one line of code that's happening in between, so I don't really need to put it inside of brackets or anything like that. I am just going to be adding to this value here, this RVP minus 4 value. So why don't I call this I don't know, let's say we're summing this guy up. That's fine. I'll leave the name alone. RBP for plus equals that value of I. Okay. So the first time through, our value of I is, it's 0. We're adding 0. The next time through, we're plussing. So we're going to add 1. Then we're going to add 2. Then we're going to add 3. All the way up until I is this value, less than 25 F value here. We're going to add each of those values to our initial value of RVP minus 4. All right. That will get us through the loop, right? And when the loop is all said and done, right? So when it's no longer less than, okay, we are going to move that value in RVP minus 4, right? This value that we summed everything into EAX. So that is our answer. So basically what we're interested in at the end of it all is we're going to want to say something like print, percent %D, RVP 4, whatever we call that variable, right? If you came up with a better name for it, if you wanted to call it sum or total, that would all be great too. Okay, I left it simply, based on its location on the stack here. Okay, but that should be our final value of what A will be, right? And so that's a summation. Right. So we can actually do that. We can do that if we wanted to in Python or in C. So for speed, why don't we do it in Python? All right, we want to say, I'm going to call it total. Okay, total is going to start as this value here. Okay, and then we can do something like for I in range, and now it's going to be this guy here. Okay, so this is how many times our loop is going to increment, and I is going to be all the numbers from 0 up to this number minus 1. And what we want to do each time is we're going to take total, and we're going to add to it, so plus equals this I value. Okay, so that should be able to show us what the final value of total is, right, once it's run through that loop. Right, so this guy here ought to be, if we've done it right, our flag, I don't know if I copied it. Oh, I probably didn't copy that right either. Okay, so I'm going to copy that again and head back over to our window here. Okay, let me move this up a little bit. And what we want to do is say PicoCTF, and here's our flag. We want to paste it in, just like so. All right, so if we've done it right, okay, that's a big if. That's always a big if, but we at least have something we can test out as being our flag. Copy that over, paste it in here, and good. All right, we were right. All right, good stuff, right? That was a fun one. We got to do a little bit of actual reverse engineering, seeing what it comes back to look at as not only C code, but also some Python code, right? All right, so with that, we can, we got this complete. So I'm going to delete 3 words and leave it as complete. And should be good on baby step number 2. Great. All right, so we're going to move on to baby step number 3. So make directory, GDB Baby Step number 3. Change over to it. Copy our README file into this directory, and we're going to start editing it. Toss our details down here. All right, what do we ask for? Oh, now for something different. Okay, wow. Okay, they're going to change it up on us now. We just got into the swing of finding out what was in EAX. Let's see what this has in store for us. All right. something a little different. We've got a number here, right? Hexadecimal number is loaded into memory in the main function. We want to examine the byte-wise memory that the constant is loaded in using the GDB command hex examine, right, for hexadecimal bytes. That's what this means, at a particular address. So the flag is the 4 bytes as they are stored in memory, right? So if we find 11223344, then the flag will be 11223334, just like that, right? So debug this. Great. Okay, so if we go ahead now and get the executable they want us to check out, this guy, and we wget it into our environment. Cool. Let's make it executable. All right, there we go. So we can now open up our README in case there were some notes that we want to have along the way here while we're trying to debug this. And I'm going to open up. We can do this a couple of ways, right? For instance, we can look at the object dump again if we want to. Oh, I'm in the wrong spot. You guys keep putting me in the wrong spot here. Okay, so we want to go to GDB Baby Step 3. Okay, so we can object dump it. Like so. Head over to the main function with our spacebar a few times, right? And now we can see here's the main function on our screen, and there's not a whole lot going on here. Again, right? Just a few lines of code. You've got to, if you know what it's called, this is all the function prologue here, these first few lines, and so we don't really get into assigning something to EAX until really these last 2 lines here before we start returning from the main function. So that's all that's really going on. So this value here, 2262C9 6B, gets loaded into EAX. Exactly what we were told was happening over here. That exact same value is in EAX. But we get asked, hey, how does it get loaded into memory? All right, now the value that we show here in this register, right? The register is on the CPU. When we load it into memory, okay, our memory stores it in something known as little endian byte order, which means we're just going to actually reverse the order of these bytes. So knowing that, right, I can put into to our notes here, we need to convert the number that we've been given we need to convert the number into little endian byte order. Several ways to do that. You could fire up a Python program to do it if you wanted to, or load it into CyberChef or something like that. But honestly, all you need to do is find these byte portions here and switch them up, right? So the totals to flag looks like this, PicoCTF, and they want the actual 0x in front of the hexadecimal number, 0x. So what I need to do is take each of these bytes. I'm going to start with the little end, right, of this, the least significant byte, and I'm going to write that first. So that's the 6B. So that's the 6B. Then there's the C9 after that. If I go 1 byte before that, that's this 6.2. And the final byte, that was the first byte, the largest or most significant byte, is this 2.2. So telling me, hey, if we went backwards that way, that should be our same value in little endian format. Okay. Now we could again, fire up the debugger. If you didn't know exactly how to do that, they did show us how this works. So I can open up GDB for our file here, and I do have my GDB go into the TUI mode because I like that a little bit more, but I do have to fix a couple things with it. But if we look at the assembly that's in here, right, we see the exact same thing happening here. So what I can do, and I can look at the register values as well, but I'm really more interested in what's happening in memory at this location here, which is what we got told. So we want to make sure that this command has happened, right? So we move this value here into RBP -4. So I'd like to set a breakpoint at this location here, main plus 15 bytes. So I say break at star main plus 15. Okay? And now you can see I have a breakpoint right there on that line of code. I'm going to go ahead and run the program. Okay? And we can see that we've gotten to this line of code inside of our program. Okay, but it hasn't happened yet. So remember this about breakpoints and stepping through inside of a debugger, right? It's always highlighting the line of code that's about to occur. So we are about to move this value into this memory location, right? If I, by the way, prove this, the thing we were told to do was examine the 4 bytes at this address. So I'm going to put that exact command in, examine 4 hexadecimal bytes, 4xb, at this address. We need to put I think a $sign here, which is RBP. You can see right here, RBP -4. Right, I'm going to leave off the 0x because again, it doesn't change in hex to decimal. Right, and as I do that, we can see this number is just zeros. Right, it looks like these four bytes of zeros when there's clearly a value here that should be loaded into that location. So what I'm going to do now is I'm going to step. I'm going to do one step. You can do SI or you can do NI to step an instruction or go to the next instruction. But when I step this instruction, we can see that it has executed this line of code. And if I go back and execute the examine command again to look at those same 4 bytes, we can see that now that variable has indeed gotten loaded in, right? This 4-byte double word has been loaded into memory at this location. And we can see it's in the order that we showed over here, right? In little endian byte order, right? The 2.2 is actually last, right? The 6.2 is second to last, right? The C9 is before it, and the lowest byte, the least significant byte, the 6B, comes first as it's loaded into memory. So we can see that it changed the byte order, moving from the CPU over into RAM. All right. All right, so only thing remaining really to check that that we got the right flag and PicoCTF agrees with us. So I copy this and paste it over here. And hooray! All right, we got another one. Okay, looking pretty good. All right, only one more of these GDB Baby Step challenges to go. So let's go ahead and mark this complete. That's what I'm trying to do here. I'm going to delete 3 words. Nope, I hit the wrong button there. Delete 3 words like so. It's marked complete. And now 2 capital Z's to exit Vim and save. And we're going to head back over to our GDB window, which we no longer need. So I'm going to hit C to continue through this program. We can see that it has now finished executing and exited. So I can quit GDB. It has done its service. All right, and so now we are ready to head to our last GDB Baby Step challenge. All right, let's go ahead and copy this over. GDB Baby Step 4. Okay. I need to make a directory. There we go. Make a directory, GDB Baby Step 4. Change to that directory and copy our README to this location. Okay. We are going to go ahead and start editing it. And in our description, we're going to paste our instructions. All right, so what happens here? Main calls a function that multiplies EAX by a constant. The flag is that constant in decimal. Okay, so if it's 0x100, we need to convert it to decimal to be 4096. All right, so there's clearly some executable here that we need to download and finish working with. So I'm going to open up another window, and I'm going to remember that I need to change directory into, these are called GDB Baby Step 4, like so. Okay, so we're going to wget the challenge from here. Very good. We're going to make it executable. Okay. And now we want to take a look at, okay, what is the code in here, right? Where do we see EAX getting multiplied by this constant? We might be able to do it in object dump. I'll go back to radar. Why not? I don't want to tease radar too much. So I do. It is really useful, but these are somewhat simpler problems, so you don't necessarily need the full functionality. But it is good to get used to. So this guy's called debugger version D. I'm going to seek to the main function here. And this time I will do the analysis, right? It may be overkill, but that's okay. So we type in a couple of A's here, right? 3 A's is probably more than enough for doing this. And it is going to gather some good information that might help us understand what's happening inside of this executable a little bit better. Right? In that case, I'm going to hit capital V here to go into visual mode. And now I'm seeing the data in visual mode. I'd like to see the code. So I'm going to hit P to print it in that other format here. Okay, I can hit P a couple of times, by the way, and cycle through other ways of looking at it. Like here's the debugging version where I see registers and some of the stack, right? And I can hit P a couple more times and it's showing me just different views, all right? And I cycle all the way through. All right, so here we are at the main function. By the way, I'm going to look back one, and it does look like there's another interesting function up here called function one. I'm going to go back one again with a capital N is scrolling up to other functions, and it looks like it's just that, right? It looks like only main and function one are really probably interesting at all. All right, so main calls a function that multiplies EAX by a constant. Flag is just that constant, right? So we don't need to know what the result of the multiplication was or anything like that. In fact, it just tells me main calls this function. So we can see down here, which is nice. Here's a call to function one. And we can see them both being defined. So here is function one just above main, right? I am right now going to ignore all the rest of what happened in main because I was told that I just want the constant inside of this other function, okay? I don't need anything happening with main. I'm looking at this call right here, and it sends me up to function one. I'm going to analyze it just like I analyzed main in the other challenges that we did. And as we can see here, right, we're reading in RDI. That's not super important for us probably. We just have these two lines of code. We're moving some value into EAX, and then we are multiplying EAX by a constant. That's what we got told. The function multiplies EAX by the constant. So our flag is that constant, right, in decimal. Now this constant is currently in hexadecimal, so all I need to do is what I've done in the past here. I'm going to copy this, head back over to my other window, and say, give ourselves a note, the function func1 multiplied EAX by constant, this guy here that we found. All right. So that all we need to do is convert that pretty much. So we can say PicoCTF. And now same thing that we've done in the past, Control R equals, and let Vim convert it for us. Right? And that looks like it should be our number. Right? I'm going to go ahead and copy and paste this and see if that is indeed our flag. All right. Okay, and hooray, it is. Right, so there we are. Right, another major tip with doing reverse engineering is, right, don't get bogged down in details that aren't necessarily relevant to what your goal is, right? What you're trying to achieve. In this case, right, we just needed to find some other function that got called, right? Main calls this function. So we found where that function call happens. We see what the name of the function is, function one. And then we go to that symbol, function one here. That's what we need to analyze. right? And inside of that, we didn't need to analyze the whole thing. We just needed to find a constant being multiplied by EAX. And we can see only one line really does anything like that, right? So in just a few seconds, right, we were able to narrow our focus down to what we need to look for. Okay. So there we go. We've got another one done. So I can mark this guy complete. Right, we're going to go ahead and exit radar 2. Sorry, we didn't have something more complex for you to do. All right, but maybe still to come. It looks like we have a couple more challenges. So we've got these picker challenges going on here. All right, so what are these asking of us? Picker 1, there's a service here that provides me with a random number, but we want to know, hey, could it potentially do something else? Let me go ahead and launch this instance as I'm copying this over, right? So we got a picker 1 challenge. So I'm going to change that directory. I'm going to copy over our README. Into this directory and start getting ready to put the challenge description in here. All right, looks like our instance is ready to go now. So these are the instructions. It turns out we will need to connect to this remote instance here on this port number and maybe check out its source code beforehand. Okay, great. So we're going to copy this guy and paste it in. Okay, okay, good. And so we have all these directions. I'm going to bring this to another line just so it's a little bit more readable. And let's go ahead and exit this guy here and grab that challenge. Copy this link over, paste it. All right, so we got picker1.py. Okay, it looks like a Python executable, right? So we haven't dealt with Python yet. This is great as far as what we need to analyze. So I'm going to make it executable just in case that is something I would want to do. Okay, and so I would like to maybe be reading both of these. So let me open up both things here. So we can see, by the way, sorry, we've got our notes and the code that we want to execute. Vim can do both for us, so I'm going to open them in a split buffer, a vertical split buffer here. So we're going to have README on one side and the picker code on the other side. I'm just going to have two different buffers here because I don't want to mess up my window. Okay, so let's go ahead and analyze the code itself. So I'm going to go to the next buffer. So bn will do that. And what we can see is there is a function here that does a get random number, and that random number is always 4. So it looks super random, doesn't it? We have exit defined, and then we have some esoteric code in here that doesn't actually even look like Python code, right? If you scroll down into it, we can see some other function defined here that's called win, which looks like it will open a flag file and read it out. Oh, that seems quite useful. All right, and if we scroll all the way down, we can see a infinite while loop here that asks for user input. Like it says get random number, and is what we should try, which we saw was the name of a function up there. And then it appears to take that string, add some quotes to it, and then evaluate it. Okay, it looks like that's how we could call a function. So that would be a way to call this get random number function. Okay, that seems kind of cool. Why don't I go ahead and open up another window here. Okay, what I'd like to do is to test this code out, right? So I can say Python 3 picker py, and it says, okay, try entering get random number. Now this is interesting. Get random number. Okay, and sure enough, it gives me 4, which is what I saw that get random number function does. So I'm going to go ahead and quit. I think I can do quit. Okay, like so. And what I am really interested in doing, okay, it's not telling me this, but I get to enter whatever code I want, right? I get to enter whatever string I want. And when I entered the string get random number, it called the function that ended with that, right? So what about win? I'd really like to execute this because that would print a flag for me. Okay. So what if I just typed win instead of get random number? Would it then append these braces here and call the win function? All right. Good thing to check out. In order to do that, I need a file called flag.txt. So if we head over here, what I'd like to do is I'm just going to make a test flag here. I like to make one with maybe a bunch of X's or something like that. So Alt 3 2, sorry, Alt 3 2 capital X, like so. Something that's going to stick out and be obvious that hey, this was a flag. So I call that flag.txt, like so. So now I have a third file in here called flag.txt. I can cat that out, flag.txt. So if I was able to find that, that should be printed out. Cool. So if I now take a look at this guy here, I can run the program again, Python 3 picker, and instead of get random number, which gets called, that works, why don't I just try typing win, like so. Oh, boom, hex 5/8, a bunch of them. And if I look that up in the ASCII chart, that would definitely correspond to an uppercase X. So it looks like that did successfully print my flag for me. Okay, well, if that's the case, then that should work on their instance that's running here. So what I'd like to do is netcat to their instance and see if I can do the exact same thing. Right? So netcat makes a connection to another server, right? saturn.picoctf.net, and on a particular port. So here's the port that they told me it's running on. So when I actually connect to that port, it looks like they're running the exact same program for me. But the program is now running on that server side. So when I now enter win, and they append the parentheses for me, and it calls that function, it's not calling the function on my system and sending me my X's for the flag. It should be sending me whatever the bytes that correspond to their flag is. All right, that looks good. That looks like it worked. I'm going to go ahead and quit. Looks like that's all I need from that server there. And what I will do now is go back to my notes here, where I got to say I was able to inject the name of the function I wanted to execute. In this case, win. And they would place the braces after me. Okay, and that resulted in me getting a string that looks like this. Now I'm going to have to zoom in again and grab all of these bytes, because the code also converts these bytes to hexadecimal. But again, just like we saw back in that C program earlier on, these look like they're all in the ASCII printable range, right? Again, by experience, you'll get to see these numbers and recognize that. Right, so what I have here is I can say, hey, my flag kind of looks like this, right? I'm going to have a opening bracket, actually I don't want to say flag in front of it, as I'm just recognizing, like so. So what I'm going to do is I'm going to get rid of that. Right here, because I do just want to replace all the spaces with commas again. So same substitution. So in normal mode, hit colon, S for substitute, then I put my slash, and I'm going to substitute a space with comma. And I'm going to do that globally, okay, with the G here. So there we go. Now I'm ready to toss this into another Python list and do the conversion. Okay. All right, so I will now need to copy that again. So I'm ready to put it into Python. Head back over to our other window here, open up Python, and get our characters equals this. All right, and we're going to just do our mapping again. I'm not even going to bother storing it into a variable this time because we saw what that was like. We just need to map the CHR function for each of these hexadecimal numbers into our cars, right? Our array of characters here. And there it goes. It looks like it gives us a flag, right? This looks pretty reliable because it's in the exact same flag format that we would expect. All right, so that looks pretty good. So if I come back over to this side here, I'm just going to go ahead and paste it as my flag. Like so. All right. Pretty confident here because, again, we got something in the flag format, but again, we want to just go ahead and test it. All right, and looks good. We earned our 100 points, right? Only have 2 challenges to go. We can now, again, mark this guy as complete. Save and quit this file. Okay, and get ready to do our last couple. So we're going to make a directory for picker2 in this case, change to it, and copy our README file. Oops, first time I've done that today. Not ever. All right, so we've copied our README file over. We are going to open it up. And now we're going to copy our directions into it. All right, we've got another instance to be launched here. All right, so I should have launched it while I was waiting for this, but there we go. It launches pretty quickly. So we want to get all of our instructions here. Paste it in, just like so. All right, it shows us the port and server we need to connect to. All right, so it looks like our steps ought to be pretty similar. Okay, I'm going to exit here, and I'm going to download with wget the code that they're making available, like so. I will make it executable, even though we're executing with Python 3, that's fine. Okay, so we've got our picker2.py. Let's go ahead and analyze both of these. All right, so we're going to open up our README and our picker side by side in just a couple different buffers here, so we can add to our notes as we check out what's happening in this file. Now, this file doesn't look too different than the previous one. Right? We have our get random number again, completely fair die, always giving us 4. Exit. We got these esoteric functions again. If we can ignore it, we should ignore it, right? These didn't end up mattering last time, so I read all these lines of code if we don't have to, right? We will know later on if we do need to go and analyze them, right? So again, I have the win function. The win function itself, I know it was what I needed, right? It prints the flag for me. So again, I probably don't need to analyze it, but I would sure like to call it, right? So I'd love to call this win function. Again, no new data there. We have another esoteric function. I'm going to skip it. So we come down to the end, and we can see that once again, we have a infinite loop here. While true, we're taking some user input. This time, however, we're filtering it. So there's some kind of filter function here on this user input before we just slap on these parentheses and go ahead and call it. Okay? Interesting. And what it does, it looks for the filter. If we look up here at the user input, it looks like if win is any substring inside user input, right? If any part of it is win, like if it's the word window, right, it's going to return false. Okay, so I certainly can't just put win in for my string, right? So as long as I don't have something that has the words win, right, these 3 consecutive letters, it should return true and then still try to evaluate that. All right, so I might, at this point, go to my other buffer, my README, and say, this version filters user input and won't let me directly inject win. All right. But that gets me thinking, what can I do? I know I want to execute win. I'd like it to be that string, but the string itself just can't be these 3 consecutive characters. But what other things could I do? Could I potentially take advantage of the fact that nothing else is filtered here, right? And do something that will build the string, right? So if I head over to another Python shell here, right? We can always bring up the Python interpreter and kind of check out things that work, right? If I do this for win, right? Well, that's how I can get the string win. But I can't just do the string win just like that, right? Because that's going to get filtered, right? All 3 of these letters would be inside, right? Of that, right? So just to show you, win, right? In win, which is what shows here, right? I'm looking for the word win inside of the string I entered, right? And that is true, right? But if I also did a longer word like window, right? Oh, sorry, other way around. I'm looking for win in the other string here. Like, is it in the word window? Yes, that is true. Okay, so those things would get filtered. I can't say win. I can't say window. Anything that win is in, I can't use, right? I can't do swindle or something like that. All right, I don't want to like delay this or anything like that. But okay, we can't do something where we have the letters win consecutively like that. Okay, I think we kind of get that point. But what other things could I do? Right? Do I have to make a string where it's where we just put out the characters win back to back in this way? Couldn't I break the string up like so, right? And just concatenate the individual characters like so? Like this, right? So now I have the character W, and I'm concatenating the character I, and now concatenating the character N. So win is in that, okay? Right, that is the word win. However, what if I did that over here, right? So let's try it out. Get to the right file, right? Picker2, like so. Okay. So what if I tried to do exactly that? Now let me go ahead and get a flag again. So Alt32 X's. I don't want to forget to echo this flag.txt. We'll hit Control A to go back to the beginning of the line and actually make this an echo into that guy there. So there we go. Now I have a flag file, which if I get this working, should print the flag for me. So if I now execute this guy, Python 3, picker2, right? What if I tried to just build this string, right? W concatenated with I, concatenated with N. I can't do that, right? String object is not callable. Perhaps I missed a comma. That's no good. This is no good because, right, as input, I'm kind of including all these quotes here, and it's thinking I'm trying to make this bigger string object. It's not just this input string that I can directly evaluate. But couldn't I evaluate that myself? What if I took this exact string that I wanted to do here? What if I called eval on that, right? So that it would concatenate all of these together first. Okay, so now I'm calling eval as a function, right? This is just a string, which would ask for this to be done together in eval. And now, look at this. Because this got evaluated and joined the W, I, and N together, right? And then went to an eval over here, yet again, right, as user input, where it added the the parentheses to it, that was able to call win, but this guy was false, right? The filter was false because WIN as 3 consecutive characters is not found in this string here, right? This right now, as I entered it, is just a string. It's not being evaluated before the filter, right? So the evaluation doesn't happen until after the filter occurs. So right now, this is just a bunch of characters that look like code to your human eye, but not necessarily to the system. So win, the substring, is not does not appear in here. So I am able to sneak it through the filter, and I can see my capital X's, those same characters again. So this is great. I'm going to copy this, head back over, and say, however, I can use my own eval string to sneak a sneak an operation past the filter. And that looks like this. Paste. Okay. So now I'm going to go ahead and test that. Now, I mean, I've printed my own flag of X's here, but that's really meaningless. So I'm going to go ahead and quit. And what I'd like to do is try the same thing on the server side, right? They've given me, here's where I need to connect to. So I'm going to make this connection here. Now I'm running this against the actual server. So I'm going to copy and paste. And it looks like it still works there. Okay, pretty exciting. Let's go ahead and zoom in and copy these. And I'm just going to do the exact same thing we did last time here. Make the little Python list out of this and grab our flag. This should only take a minute. Famous last words, I know. All right, so paste this guy here. And on this line, yet again, we're going to substitute spaces with commas globally. All right, insert at the beginning our bracket, and insert at append to the end our other bracket here. Let's zoom in so we can copy that whole thing. All right. All right, so we can quit there. And now on our own side, we're going to run this in Python. What did we call this guy? Cars before? That's fine. We'll stay consistent. Here's my characters, a Python string, and I think I can actually just scroll up here. And basically, since it's the same interpreter, it remembers the last time I did this, so I'm just going to run the exact same command. All right, and copy and paste it again. Okay, copy this guy. That looks like a successful flag grab, so let's paste it over here and paste it into the solution window. And boom, hooray. All right, only one to go. All right, great news. All right, so just picker 3 to go. We now are confident that we had the right answer over here. All right, I'm going to save that. And delete our 3 words before this, mark it as complete, head out, and be ready for our very last challenge. In the reverse engineering side, of course. All right. Picker 3, change to that directory, and copy our notes over. Perfect. All right, now our last description for picker 3 is, let's go ahead and launch this again. Okay, great. So we have very similar instructions here. Can we figure out how this works? It might be similar code again. We're about to find out. Okay. I'm going to go ahead and download it now. We'll wget this code. And since we know what server to connect to, that's all good as well. So we paste this. We've got this, chmod plus x, bigger 3.py. That's fantastic. There's probably a flag that I'm going to need to work with again, so I'm just going to go ahead and preemptively create a flag here. If I'm understanding the format of how this one's going. Okay, so hopefully I've got everything ready. I've got my picker. I've got a dummy flag here that I can test to make sure I've gotten the right solution. And now I'm ready to go ahead and analyze that code. So let's analyze our README as well as the picker. Okay, so our README, we're ready to take some notes. We're going to go to our next buffer, which is our picker 3. All right, so what's happening here? If I go up to the very top, we define a few constants, right? If the user is alive, a function table size. Okay, this is interesting. A function table entry size up to 32. Something about a table getting corrupted. Okay, this is interesting. Sounds like there's function tables here, so I may be able to dynamically work with like what functions are defined in here. And if you mess up, I guess you could potentially corrupt this, or maybe you could intentionally try to corrupt it. All right. So something to reset the table, and it looks like our function table starts out with 4 functions called print table, read variable, write variable, and our old favorite get random number here. Okay, cool. All right, so we can see that there's actually other functions defined that are not inside this function table. Things like check table. We can see here get func. All right, so this may be some code to get a function. Right now, again, I am not looking at each line of code in these. I'm only going to do that if I actually have to. Okay, something that will print a table. Right, if these are well named, then hopefully they do exactly what they say they're going to do. And if that turns out not to be the case, then I'll go through and analyze if it does something different. Okay, so we again have another filter, right? We're filtering a variable name. It looks like we have a regular expression here. So you got to kind of learn regular expressions, but it looks like the beginning of the line needs to start with upper or lowercase letter, and then all the other characters need to be upper or lowercase letters and or a digit. Okay, each one of them needs to be that until we get to the end of the line. All right, so it looks like standard rules for an identifier in a program. Okay, we've got the read variable function here. So hey, read some variable, and we have a filter on hey, what name is potentially going to get read. Okay, so that goes through the filter we saw here. So it needs to be a standard identifier for a real variable name. Right, and then we have a write variable, so we can also write to a variable name. So we can create some new variable inside of the space here. So some name equals, right? So we're going to filter for the variable name, but then we also get the input of what the value of that variable should be. Okay, now this is interesting. Okay, so I get to not only make the name of a new variable, but also what value is associated with it. Kind of cool. Right, so now this needs to respect another filter here, which is this guy. So this filter says, hey, this new value, it can't have a semicolon to kind of concatenate multiple commands together. It also can't have parentheses, right? Like it's trying to call a function or something like that. And if it was, I wonder what kind of function we would be calling. All right, so we have a whole call function defined here, which hopefully will do that for us on our behalf. Underneath that, we have a few dummy functions, right? It just tells me I'm in this dummy function. Maybe this is good for testing. My trusty random number being 4, as always, all right? Come to love that. And we have our win function yet again. So clearly I would like to have this executed and show me my flag again in hexadecimal notation. Right? Handy help text here. If I don't know how this program works, it should tell me what I'm able to do. I can kind of read it here. I can also read it as the program is running, probably, if it has a way of showing me help. And it looks like help is one of the options down here at the bottom. Okay. All right, so that's good. It looks like I'm going to get while the user is alive, I'm going to have some input. As long as I'm not quitting or asking for help, right, this help right here, it is going to, or resetting the function table to those original 4 values we saw at the top. We are going to take some choice, right? Choice is either 1, 2, 3, or 4, right? If it is one of those 4 choices, we're going to call a function with some kind of associated number, right? Function 0, 1, 2, 3, or 4, some function that's known in that function table, it looks like. So it looks like these are probably going to correspond to those 4 functions that we saw in the function table way up at the top, right? And that's what our help is telling me. Execute the first function, second, third, or fourth function in that function table. I'm going to go look at them again real quick. I hit GG to come to the top, and I can see it's print table, read variable, write variable, and get random number. All right, I may be, at this point, we could analyze line by line the code, but why don't we execute it and see if we can get a feel for how this works. Okay, I'm going to do another split buffer here, cd to picker3, right, which is what we have. And let's go ahead and execute it. Picker3.py. All right, I don't know how it works. I'm going to ask for help, right? And this is the exact same help text that I saw before. So it looks like I can do things like print the table. That's option 1, which just prints the exact same table I see here. So I can tell what the different functions are, right? I can read variables, write variables, and maybe that's interesting here, right? I could read a variable. What's the variable name? Variable apple. I don't know. Maybe there's a variable called apple. Uh-oh, it crashed, right? It looks like there was no variable named apple in there, and they didn't know what to do with that. Okay, so hey, no harm, no foul. I can go right back in and try again. What if I now try to read a variable that I know does exist in here? Something like win. I ask for win. Oh, this is familiar, right? If we've done Python, it tells me, hey, this is some function defined at a location. So this is confirming that it is a variable that exists inside of memory here. Now, what if I want to call a function here, like get random number? So if I hit 4 for get random number, it does indeed give me, hey, that completely random number here, which is 4, and always is 4 as it has been this whole time. That get random number function isn't super useful to me, all right? But a function that is useful to me is win. So I wonder if I could potentially replace one of these functions that's not super useful to me with the win function and end up calling that. That is more than likely what a function like write variable does. Why don't I give that a try? So if I hit 3 for write variable, here's a variable name I want to write. Like I could write apple if I wanted to here, right? Let's go back to apple. And I could say, hey, what is the value of this variable? Well, if I put win in, then it should bring that that back to me, right? It should show me that. It should bring that object right into this new variable apple that I'm creating. So if I type win, okay, it looks like that worked, right? I didn't get an error, at least the program didn't crash. That's great stuff, right? So, but now if I type 1 again, right, here are the functions that are available to me. Can I execute win now? It's not one of these 4 functions, so how exactly would I do that? Right, 4 is still getting this random number and not really executing the win. All right, but I have apple in memory now. So there may be some clever thing I could do to manipulate the table itself, but why don't I try writing to this table again? But this time, why don't I just kind of, if it will let me, overwrite one of these existing functions that it is allowing me to call, like get random number, which isn't super helpful. So now the variable I want to write is get random number, like so. And if I enter the value of it, why don't I put the value as being win? Okay, now if I look at my table again, I have these 4 functions, but the get random number function should have been redefined with the same value of what the win function was. So if I now call that, it is in fact showing me my flag, right, of my X's here. All right, that's great stuff. So it looks like if I head back to my other window here and go to my notes, I appear to be able to overwrite existing functions with previously existing functions. So my solution, overwrite get random number with win. Okay, I'm going to try doing exactly that. Okay. Now, of course, right, when you're doing this, you could make more detailed notes, right, if you want to do a nice comprehensive write-up. But right now, at least we're getting all the bones that we'd need to be able to go back and make those better, right, all the way through, right? We've now solved all these challenges, and we have, 70, 80% of the work done for if we want to kind of make those available, right? Oh, good. So now let's go ahead and quit. Okay, and I'm going to go ahead and try this on their side before my time runs out. Okay, I'm going to go ahead and paste. All right, and now I'm talking to the actual server. So if I do the exact same things, if I hit 3 to write a variable, and I'm going to write get random number and give it the value of win, and then go ahead and execute get random number, and it should, just like it did before, show me these characters. That should be the flag. All right, so very quickly, we can go through and do our exact same process. Okay, to go in insert mode here and paste this, and I'm just going to go ahead. I'm not going to talk about it too much, but we know we want to replace our spaces globally with commas and make this a Python list. Whoops, did that wrong way. Helps to look at your screen while you're typing. Okay. So we're ready to copy that over. And cars equals this. And let's scroll up to the last time we did this, right? So, and it looks like we've got a new flag. All right, good news. Good, because my voice is just about dying, right? Okay, perfectly timed getting through all this, right? So if I paste this now, it looks like we should have a good flag. And if we come back here and paste and hit submit, hooray. Especially some confetti now, right? We've cleared the board. A little more fanfare, okay? But yeah, okay, that is the walkthrough of all of the reverse engineering challenges in the Pico exclusive, right? That can help you get some good beginner experience to maybe give you the confidence to attack the reverse engineering next week during the PicoCTF. Okay, good luck.